Hi everyone. This video walks through completing Packet Tracer Assignment 4.2.4.5, Connecting a Wired and Wireless LAN. Now for this particular assignment, there are PDF instructions that you can print out for your own benefit, but you don't have to turn those in to me. Just this packet tracer will do, and it is graded. You see the completion 0 out of 80 right now at the beginning, so it is going to track all the stuff you do. Now in this lab, going along with this week, remember chapter 4 is the network access layer. Now the network access layer is the bottom layer, kind of the uh, first layer, if you will, or bottom of the stack that we looked at for the TCP IP model in chapter 3. But the network access layer also corresponds to two layers. They kind of combined them together from the OSI model. So the OSI model layers that we're kind of referencing are the physical layer, especially that's concerned with cabling, whether it's wired or wireless. What wireless standard are you using? Is it an Ethernet cable or a coax cable or a fiber optic cable? All those things are important for how you have your network set up, because even though stuff can communicate that is wireless and wired, that doesn't matter. But to get the communication to jump onto the network, we have to know those types of things. So again, the TCP IP model that we're really looking at and focusing on is the network access layer, but again, that corresponds to the two layers, the data link and the physical layer from the OSI model. So they really work closely together, so they just kind of combine them together into one layer. All right, so this week again with this lab, we're focusing on cabling. So in part 1 here, it tells us to connect the cloud to router 0. So remember from our other lab assignments, this lightning bolt symbol, this orange lightning bolt, is the cables. All right, so you'll see a lot of array of cables here. From console, if you hover your mouse over each one, it'll tell you what it is, to copper straight through. So for this particular one, it tells us to choose the correct cable to connect router 0 FA00 to cloud Ethernet 6. So we're going to connect the copper straight through from router 0. So we click on router 0. FA00 is fast Ethernet 00. And we're going to connect it to cloud Ethernet 6. Okay, and you see the lights turn green. Now the green is good. That means that our links on each side is up. Now in future labs, that does not mean that connectivity exists, but that does mean that the links are working and it's firing back and forth. But it does not mean they actually work as far as network connectivity is concerned if you're trying to send a packet from a source to a destination. But that'll come much later in the semester. All right, but for now that is good. Okay, so it also tells you that the cloud is a type of a switch. So one thing to remember is if you're connecting devices that are different types of devices, like a router to a switch to a PC, or something like that, those are different devices. So you'd actually use a copper straight through cable for those. Okay. Now the next one says connect the cloud to the cable modem. Now some of you may have cable modems at home, through Suddenlink or other Time Warner, other whatever cable company you may have in your area. All right, so we're actually going to do that here. So if we hover our mouse over the blue one here, it's like a blue zigzag symbol. All right, we are going to click on that one because that's the coax cable. So we connect that from the cloud, coax 7. You can almost see the connector there. It's kind of like that copper middle that sticks out that you screw on the coax cable with at home. And we're going to connect that to the cable modem port 0. So again, it kind of looks like the same little connector there. Oops, sorry. And our lights turn green there. So that's what we want. All right. Part 2, it says connect router 0 to router 1. Now these are like devices, but when we're talking about router to router communication, a lot of times they'll use something like fiber optic cables or a serial cable. So here we are going to look for the serial cable. Now there are two types. It does not matter for this lab. In the future it will, because the DCE that you see here with a little clock symbol and the DTE are basically like the male and the female version of the cables, right? So the end with the pins or without the pins. But for here, we can just use a serial DCE with the clock. Now later in the semester, we will have to worry about which end is which, but right now we don't. So we're going to connect router 0 serial 000 to router 1's serial 00. Now the naming of it really doesn't matter. As far as you see, the first one had 3 numbers, this one only has 2. It just really depends on what the router decides to register those ports as. It's just a name. It's not going to matter for connectivity though. Here, connect router 0 to Netacad PKA. So now we're going to connect router 0 FA01, which is a fast Ethernet, to Netacad PKA FA0. Now, if we look, this is Netacad PKA. All right, that is a server. So that's kind of like a end device or a computer. So technically, and you can tell it here, it says routers and computers traditionally use the same wires to transmit. So when we go back to our first example, we were talking about the router to a cloud switch, right? They're different devices, so we can use a copper straight through. Now, typically, and this has been, for a long time in networking, if the pattern, if you look at the ends of your Ethernet cable, you see orange, white, blue, white, brown, white, and green, white. So those patterns of cables in a copper straight through are identical on both ends of the cable. On a crossover, it actually, the ends of the cable are punched down, is what it's called, in that plastic end connector in a different array on one end than it is on the other. All right, so that allows it to be able to communicate. So in new devices, it actually doesn't matter because there are smart network interface cards that'll switch it accordingly. So that's great for us as network professionals. But in this particular lab, it tells you we don't have that luxury. So we really do need to make sure we choose the copper crossover here, and we're connecting router 0's FA01 to the Netacad PKA FA0. All right, so we get our green lights there. The next one in step 3, it says connect router 0 to the configuration terminal. So remember in like our second chapter, we used a console cable, which is that blue one down there, the Carolina blue one, and we connected it from the RS-232 port of the computer to the console cable of the router. Now remember, that is just for configuring the router. All right, so if we go to configuration terminal, or the PC itself, desktop, terminal, okay, and then we can configure away on our router, right? That does not provide us any type of network connectivity. It's actually called an out-of-band connection because it is not providing internet connectivity by any means, all right? Now, the next part we're doing, it says connect the remaining devices. So we're going to connect router 1 to switch. Okay, so it says choose the correct cable to connect router 1 FA10 to switch FA01. All right, so over here we're going to be looking for those two, and if you had chosen the wrong cable, I'm just going to go through that, just choosing the wrong cable. So for instance, let's say I chose a copper straight through, or crossover, right? If I try to connect that here, it says the cable cannot be connected to that port, so you know it's not correct, right? If we look at it, when we click it, the fiber is the one we want to use, the orange, okay? It looks like a fiber optic end. Now, I know you may not have ever seen one of those, but it almost looks like a little plug. It's kind of has 2 prongs on it. Really doesn't look like a power cable, but it's kind of unique. I think our chapter actually has a picture of one. So you kind of plug that in there. So it's the fiber to fast Ethernet 1.0 to the switch fast Ethernet 0.1. And you'll see both of them eventually turn green there. Now, the thing with fiber is it does offer very fast connections, but it also is very expensive. So a lot of times people don't put in fiber unless absolutely necessary, unless it's carrying a lot of traffic or something like that. So again, it's kind of foolproof. You have to be able to connect the right type of cable there, but fiber is the one you want. The next one says connect cable modem to the wireless router. All right, so we're going to connect the cable modem to the wireless router on port 1 to the wireless router. All right, so if you got one of these at home, you know that you need a Ethernet cable, so you can just use a copper straight through to connect the cable modem on port 1 to your wireless router to the internet port. So that kind of gives it the ability to send the internet to all of your wireless devices. Now, if you've got a wireless router at home too, you know that in addition to wireless stuff, like they got a home PC here and a home printer wireless, you can also cable devices to it. So a wireless router almost acts like a switch as well as a router, which is very nice. It kind of gives us more ports available to connect to. So the last one we're going to do is a cable to connect the wireless router Ethernet 1 to the family PC. All right, now keep in mind what I just said. The wireless router is routing packets back and forth to your cable modem to send it out to, the internet, then to the internet world, the World Wide Web. But to the individual end devices that you have at your house, it is actually acting like a switch. Okay, so we're actually going to connect the family PC via copper straight through. Okay, so the copper straight through Ethernet 1 to the family PC fast Ethernet 0. And that gives us 80 out of 80 for all our connections. So you can kind of get the gist of how you might connect things together. You may have had experience with that in your home network. Obviously, you'll have a lot of experience in that, connecting them in packet tracers, so that's nice. Again, it kind of duplicates just like a real world situation. So if you click on any one of these devices like router 1 here, you can actually zoom in and see what would actually be there. And they really function. If you click the power button here, it'll actually turn that off. But it's locked for this assignment, but it'll actually turn that off. Here you can kind of see the 10BFX. That is actually a fiber optic standard. Here, this is a fast Ethernet port. So it just looks like your standard Ethernet plug. It has a console port, auxiliary port. These are your serial ports up here for cabling. Some of them have USB ports. You can even take and add different ones. If you look over here and click through these are actual ports that you can add to your device. Now you'd have to turn it off first because we don't get electrocuted in packet tracer, right? But no, you really do have to turn it off first, just like a real world situation, to be able to add to them. All right, same thing if you click on the cable modem here and zoomed in, it may look like the back of your regular cable modem. It's got the coax cable, the fast Ethernet cable that you plug into here on the back of your wireless router. All right, you got your 4 ports up here that you can plug into your internet port. So all, your home PC, all right, you can look at it. You can actually turn the power off there. The CD drive doesn't eject, but you can look at it there. Same thing for this switch. You can see how many ports are available. So that's great, and this actually will be useful in your next lab assignment. So hopefully this helped. If you have any further questions, please contact your instructor.